Hi everybody. In this video we're going to set up an NTP server. So let's get right to it. We're going to be using Ubuntu Server 20.04 for this. It's running on a Raspberry Pi. The server has been configured with a static IP address, and that's all there is to it. No other configuration has been made. So before we start the actual NTP server itself, I would like to make DNS entries for it. So let's go ahead and do that. Hmm. Okay, so that's our domain controller. And okay, so here we're gonna do add a host, and we're doing NTP. So this is going to be ntp.lab.local, create PTR record, the IP address is 10.192.172.20. That's going to be the P server, and that's that. Now we can log into ntp.lab.local, and okay. So first thing we're gonna do is sudo apt update. It has been updated. I just want to illustrate the process, but this has been updated today, so. Uh, Alright, so we're going to do sudo apt install ntp. So next thing we want to do is go to the settings. So or we can just do it from here. Nano, Etsy, NTP. Okay. So what we're gonna do, okay, let's remove these lines. And we're gonna put in the lines for the region that we're in. So we can just copy these, put them here, and oops, now, now, and we can save this. So we're going to, that's fine. Can delete this comment. Where is this thing? Okay. Oh, I'm saving it. Okay. All right. Gotta do sudo. Okay. Right. There. So we'll just wipe this. There. We put those servers in there, and now we can save and exit. Okay. What was that? Sudo system systemctl enable NTP. So this will enable the service on your machine. Now sudo systemctl status NTP. Looks fine to me. Now we need to allow the firewall to, we need to make a rule on the firewall to allow the traffic from our NTP clients to establish the connection to this NTP server. So we're going to do sudo ufw allow from any to any port 123 protocol UDP. And we are done. Now, we should be good. Now what we're going to do is configure an NTP client, and we're going to use a Cisco switch for that. So let's open up PuTTY. Hmm. That's a local Cisco switch. So it's going to be admin. Okay, so what we're going to do is conf t. So IP interface brief. Okay, so we have that. And IP DNS domain NS. Just a second. Let's see, the syntax here will be IP name server. IP name server. And we're going to be using 10.192.172.10 and 10.192.172.11. There. So now we can see if we can ping ntp.lab.local. There it is. We're good. Now, just to set up our NTP server. If you don't have a DNS server, you can just put in an IP address of your NTP server. I mean, if you don't have DNS set up, you're not using DNS for whatever reason, just put in the IP of the NTP server. But here we're using DNS, so we're going to set set. That's not right. Conf t set. Hmm. Okay, conf t NTP server, and that's gonna be ntp.lab.local, and show a clock, and there's our NTP server working just fine. Show NTP status. Clock synchronized stratum 3 reference. That's our NTP server right there. Nominal frequency is actual frequency. Precision is good enough. NTP uptime. Resolution is reference there. Clock offset is root delay is okay. Oh. Last update was 16 seconds ago. So that's it. Now we're gonna save. So what I want to test, if you just needed the configuration, this is it. You're good. What I want to test is I'm going to reboot both the NTP server and the switch and see if it still works, because the switch has no RTC. It will forget the time, but if you just wanted the configuration, then you're all set. But we're gonna reboot the NTP server and we're gonna reboot the switch. Make sure the configuration is saved, and we're gonna reload. Reload. This is a lab. There's nothing on this switch that can't be down for a couple of minutes. So you wouldn't want to do this in a production environment, of course. So once they both come back, I'm gonna relog into them, and we will see if the NTP works, the NTP server works properly. So that way, since this is working on a Raspberry Pi, well, this doesn't have a RTC either, so when the Raspberry Pi boots, it's going to update its time itself, and then the switch will do its thing and go to ntp.lab.local and update its time there. So let's see if we are back online. So say restart session. This is an older Raspberry Pi, so it takes a little while to boot. That's not command ping ntp.lab.local -t. Well, the Raspberry Pi is actually connected to that switch, so the switch will have to come up first before the Raspberry Pi is able to establish a successful connection. Forgot about that for a minute. But that's okay. I mean, once the switch is booted, the Raspberry Pi will have network connectivity. Switch taking its time to boot up. There it goes. Okay, that took a little while because, well, it's a Cisco switch, so it's not really meant to boot up fast. It boots up when it boots up. So let's restart this session, log in. That is our NTP server. Okay, so show. What? I'm not on a switch. What did we use? Status. There we go. Error resolving pool.ntp.org. So it didn't resolve it yet. Show date. Date. So we don't have the correct time yet. So it looks like since the Raspberry Pi came online before the switch, it tried to resolve it and didn't, and it tries. Let's see if let's see how long it takes to retry if we don't do anything. I wonder how long it will take by default. Clock is unsynchronized. Okay, there we go. We got kicked off. I believe that's because it finally got the time and the SSH session timed out. Let's log back in Ubuntu. And what time is it? And status. Um, nope, it looks like it's not fetching the time. If the internet ping google.com. DNS name resolution works. So I'm not sure when it's going to listen on soliciting packets transmitted, packets received. Since oh, I think it already got the time. It's no, it didn't. Okay. I just want to test to make sure that it actually works if there's a power loss or if it reboots or after an update by itself without any. There we go, it's updated. So it finally started working. So it took some time to synchronize and now let's see what our switch is doing. And that. And show clock. This clock is obviously wrong. Show NTP. Okay, enable. Mhm. Show NTP status. So clock is not synchronized. Nominal frequency. Reference time. Never updated. So I think the switch is going to take its time to actually do this. Since I'm trying to make sure that everything works on its own, I do not want to force it to update because the idea is to make sure that these devices could update themselves. So logging. So we have line protocol. So it hasn't even attempted to contact the NTP server from the looks of this. I did notice that Cisco NTP clients are not the fastest for whatever reason, so maybe it attempted it. No, it doesn't look like it even attempted it. So show NTP. Let's check the firewall. So well, it's not even active, so we should be good. Isn't the NTP client working on this thing? It finally did it. My clock is unsynchronized, but how come it has the right time? Hmm. Mm, hmm. Power switch change. Oh, I'm using the wrong command. Uh, it's show NTP associations. There it is. The show NTP status is the actual NTP server that you can run on the Cisco switch. That's what it is. But if you want to check the NTP client, that would be show NTP associations. So there's that. So it is working fine. Everything is working fine. I rebooted both devices. Nothing. I didn't need to do anything to get both of them to work the way I want them to work. So everything is good, and thank you for watching. I hope this was useful to you, and I'll see you in the next video.